experiment spectrometer holoprism. Its aim is to determine the angle of given liquid prism and angle of minimum deviation, hence to calculate refractive index. Apparatus required: spectrometer, glass prism, spirit level, reading lens, sodium vapor lamp, prism stand, etc. Formula: mu equals to sine a plus d by 2 by sine a by 2. Here mu is refractive index of prism, a is angle of liquid prism, d is angle of minimum deviation. To start with, the following preliminary adjustments should be made. The eyepiece of the telescope is moved to and fro until the crosswires are clearly seen. The telescope is adjusted to parallel rays by turning it towards distant object and is adjusted to a clear image the distant object on the crosswire. The telescope is brought in line with the collimator. The slit is opened slightly and the image of the slit is viewed through the telescope, and the length of the collimator is adjusted till a clear, well-defined image of the slit is obtained. Leveling the prism table by using a spirit level and leveling screws. The vertical crosswire of the telescope should coincide with the vertical slit. Here is the two things we have to calculate by this experiment, that is to determine angle of prism and angle of minimum deviation. The procedure for angle of prism is: the given liquid prism is mounted vertically at the center of the prism table with its refracting edge facing the collimator, so that parallel rays of light from the collimator fall almost equally on two surfaces of liquid prism ABC as shown. As a result of reflection, an image of slit is formed by each face of the prism, and this is located by the reflection and image by the naked eye. The telescope is then moved to that position to view the reflected image. The telescope is fixed at the position by working the radial screw. The tangential screw is adjusted until the fixed edge of the image of the slit coincides with vertical crosswire. The readings of circular and vernier scales A and B are noted for the reflected image on the left. The telescope is then moved to the right and the reflected image on the slit is made to coincide with the cross wire. The readings of both verniers A and B are noted. Difference between vernier A on left and right and vernier B on left and right gives twice the angle of the liquid prism. Half of this gives the angle of liquid prism. After doing angle of prism, you should find angle of minimum deviation. Rotate the prism table in such a way that one refracting face of the liquid prism faces collimating lens, and rotate the telescope and view the refracted image through telescope. Viewing the refracted image through telescope, rotate the prism table slowly in such a direction that image of slit shifts towards the direction of incident ray. It will be found that for one particular portion of the liquid prism, the image just retraces its path. Adjust the telescope so that the image of the slit just touches the vertical crosswire. Now the liquid prism is in minimum deviation position. Note the readings of verniers A and B. Remove the liquid prism and turn the telescope to the direct image of the slit. Note the direct ray reading of both verniers. The difference in vernier A reading of the minimum deviation portion and direct ray will be given the angle of minimum deviation. Similarly, vernier B differences are found. Some readings for table 1 and 2. For angle of prism, we should take reading of image reflected from one face. an image reflected from other face. Here the readings. To find the angle of minimum deviation, reading from one image deviation version and direct ray we should take. Now by calculating we get